imaginary numbers.
Okay. What do you got in the way of problems?
I don't have any because you didn't give us any homework tonight. So.
Okay. I can make up some for these two subjects. Let's talk about completing the square. Imaginary numbers are actually pretty easy. If I had this problem, you can tell that if I move the 17 over to the left, I'm not going to be able to come up with factors that produce 6x in the middle.
Mm-hmm.
So there's no way to factor it. I could move the 17 over and use the quadratic formula, but believe it or not, the quadratic formula was produced by completing the square. And there's lots of times where you have to complete the square to solve a problem, whether it's, converting to a vertex format or talking about conics, parabolas, ellipses, circles. There's just tons of application that require you to complete the square, including into calculus. So instead of moving the 17 over, I'm going to complete the square on the left. How do I do that?
So you divide b by 2 and
Okay.
square it.
Okay.
So it'd be 9.
Plus 9.
Mm-hmm.
Always a plus, incidentally. Now what do I have to do to the right side?
You have to subtract 9.
No. Remember in algebra, you can do anything you want to the left side as long as you do the same thing to the right side.
Oh, add 9.
Okay? Yeah. There are times where you need to do the opposite, but that's when everything's on the same side. I'll talk.
Oh yeah, okay, sounds good.
I'll talk about that in a minute. Okay. So this now turns into that, and that's why you complete the square, is because you want to be able to write it as a linear factor squared. Okay.
Mm-hmm.
Now you can make headway on this problem. I can take the square root of both sides. And subtract 3. So there's my answer. And you'll notice that looks an awful lot like what you'd get if you used the quadratic formula. In fact, it looks exactly like what you'd get. It just was a little easier. Okay? Now, let me give you a situation where I don't have the option of using the quadratic formula. Let's say I have the following. Again, I could try to factor it, but I can tell you right now there's no way to factor it.
Mm-hmm.
Okay? What if it said put into vertex format? That's the problem. Put it into vertex format. Because we've got a number of questions. This is a quadratic, which is a parabola.
Mm-hmm.
What's vertex format?
Y equals a times x minus h squared plus k.
Good. That's the most common format for quadratics. Okay? So we have to make this thing up here look like this. Now, this is a situation where we're going to leave the 11 on the same side of the equation. Only going to set it out there. Okay? And we're going to complete the square inside there. Notice that it's going to look a little bit like this when we're done. Well,
your mic's breaking up a bit.
Okay. Let me know if we continue to have problems. I'll call you on the phone and we'll finish doing the audio by phone.
All right.
Okay. what's the very first thing you have to do before you can complete the square?
You need to factor out the 2.
Yeah, you got to make sure you cannot complete the square until that is a 1. No matter what that coefficient is, if it's anything but 1, you have to factor it out. Okay? And what's left? Okay, notice I have not changed anything. And that's always what you want to do. You want to make sure that when you go from that step to that step, you don't change anything. And when I go from this step to this step, I haven't changed anything. Now, complete the square inside the parentheses.
So you'd have to divide the 2 by 2, and then square it, so you just add 2.
Add 1.
Oh, add 1.
Divide by 2, you get 1.
Yeah, 1 by...
Square that, I'm adding 1. Now, when I write that in there, what did I just do to the right side of that equation? Did I add 1?
You subtracted 1.
Oh, I actually added 2.
Oh, yeah, because...
plus 1, but it's being multiplied by this 2 over here. So I really added 2. So now, to balance everything, I've got to subtract 2. With me?
Yep.
In other words, now this line, the way I've written it, is still exactly the same as the first line. Allows me to write this as a linear factor squared, add the 11 and subtract the 2, you get that. Now that looks exactly like that. A is 2, H is 1, K is plus 9. Hold on, let me close my door so I can shut my dog up. So you have to be aware whether you are have the number on the other side of the equation or on the same side. If it's on the same side in this case, then you do the opposite of what you did. But it's always important to know that when I write a number in here, it's being multiplied by that thing that I factored out, whatever it is. So to balance it out, if I'm on the same side of the equation, I got to do opposite. If I'm on the other side of the equation, I got to do the same. Okay? That pretty much covers completing the square. Let's talk about imaginary numbers. One thing you need to know is this. I squared equal to?
-1.
What's I cubed equal to?
1.
No. I cubed is going to be I squared times I, right?
Yep.
So it'd be negative I. And then I to the 4th, think of as I squared times I squared.
So 1.
Positive 1.
Yeah.
And now that sequence repeats. In other words, I to the 5th is the same as I times I to the 4th, and I to the 4th is 1, so that's equal to I. This is equal to I squared, this is equal to I cubed, this is equal to I to the 4th. Okay, so that would be square root of -1, that's -1, that's negative I, that's 1. Every perfect multiple of 4 is going to be 1. So what's this equal to?
One.
What's this equal to?
Negative I.
Very good. All right, you got that down perfect. Now let's talk about adding, subtracting, multiplying, and dividing complex numbers. Okay? If I have a complex number like the following, and I want to add it to this complex number. It's really simple. You just add the real parts, and you add the imaginary parts. What do you get?
7 minus 3i.
Okay. That's all there is to addition. How about subtraction? What do you get?
-1 plus 7i.
Good. Multiplication is also very easy. You just FOIL it or ET it. Tell me what the terms are going to be.
10i squared.
Hold on.
Oh.
Start with that. Start with the first terms.
All right, so 12 plus minus 15i plus 8i plus 10i squared.
Minus 10i squared.
Minus 10i squared.
See why?
Yep.
Okay. Now, we can combine those two terms, but the real key here is converting that to a real number. Remember that I squared is -1.
Mm-hmm.
So the thing that I have circled on the right, what is that going to be equal to?
It's going to be equal to positive 10.
Okay, I'm going to add that to the 12. I'm going to combine these two terms, minus 7i, and that's our answer. Okay, so multiplication is just like multiplying polynomials. You can call it FOIL, you can call it ET. The key thing is to always convert what you can turn into a real number into real numbers. And that's usually I squared. You almost always have an I squared in these problems. Okay? Now, there's one last process that's not so obvious or easy, and that's division. In other words, 3 plus 2i divided by 4 minus 5i. We're not actually going to do division. What we're going to do is we're going to make the denominator real number. Okay? In the same way that if I told you, do this division over here, how would you do it?
Multiply the top and bottom by root 5.
Yeah, you're not really doing division, right?
Mm-hmm.
You're actually doing multiplication. Because now you get 3 root 5 in the top, you get 5 in the bottom, there's your answer. You didn't do any division at all, you did multiplication. Well, similar with complex numbers. The difference is that over here on the right, we cannot have an irrational number in the denominator as our answer. It goes against math convention. So you do everything you can to turn that denominator rational. And that's what we did. We multiplied it by root 5, and that turned it into a 5, which is a rational number. Now, we now have an irrational number in our numerator, but that's okay. You can have irrational numbers in the numerator. You just can't have them in the denominator.
Mm-hmm.
Okay? So with this problem, we're not going to do division. We're going to realify, what I call it, my own personal term, the denominator. And you do that by multiplying it by the conjugate. The conjugate being merely the sign in the middle is different. The other two terms are exactly the same. Okay? If I multiply the bottom by that, I've got to multiply the top. I can only multiply this fraction by the number 1. And let's examine what happens in the bottom first. Notice that that's difference of perfect squares factored, right? 4 minus 5i times 4 plus 5i. Still there? Cole? Yeah, I wasn't sure
Yeah.
if I lost you or not. So I can FOIL those out or ET them, but it's nice if you can recognize that as perfect squares factored, you know how to put it together. There's no middle term. It's 16 minus 25i squared. In other words, the middle term that comes from multiplying those and those always cancel out. I'd have minus 20i plus 20i. And that's what would normally make up my middle term. Okay? You can do it the hard way and cancel them out, but since you kind of have to do this pretty regularly with complex numbers, it's nice to know that the answer here is the first term squared minus the second term squared. That's it. You with me?
Yep.
Now, let's multiply the top out. And we do have to FOIL this. In other words, we don't have any conjugates up there. So do it piece by piece. What's the first term?
12
What next?
plus 15i
Next.
plus 8i
And finally,
plus 10i squared.
okay. Now, always start from here. The reason being is I can turn that into a real number and combine it with my 12. So do that.
So it's negative 10. So you have 2 plus 15i plus 8i.
Which is 2 plus 23i.
Mm-hmm.
And what's the bottom become?
25 plus 16, so that would be 41.
And there you go. There's the answer. Now, it's not perhaps the final answer. It kind of depends on how far along you are, but usually when you're talking complex numbers, they want you to put it into this kind of a format. If I'm going to graph it, it needs to be in this format, a plus bi. So if I take this answer and try to put it into a plus bi, what does it become? In other words, what we're really doing is we're going to separate that into two fractions. There's a.
Okay. 2 over 41.
That's a.
Plus 23i over 41.
It's actually 23 over 41. That's b. I.
Okay.
In other words, you don't really want to put the I in the numerator of that fraction. Only because I want to be able to graph that and that. In other words, here's how you graph imaginary numbers. This is the horizontal axis is the real axis. The vertical axis is the imaginary axis. Okay? So if I'm graphing a number, let me make it a little simpler than to have fractions. Let's say I'm graphing the number 2 plus 3i. Okay? Well, I go to 2 on the real scale, and I go to 3 on the imaginary scale. And that point is right there. So notice the coordinates of that point are a comma b. And that's why it's so important to take these complex numbers that you get from that and put it into a plus bi format, because then you can graph it. A is a real number and b is a real number. It's bi or it's a plus bi that is the complex number. With me?
Mm-hmm.
Now, if I go back, hold on. I go back to this, and first of all, if I see whether I can simplify that or not. I can't, right? There's nothing I can divide the top by and the bottom by. Well, what if I had the following problem? What if I had 30 over 5, and this was a 7? Okay? Notice that I cannot simplify that. I cannot divide top and bottom by 5 or any other number. But once I've turned it into a plus bi format, it becomes 35ths plus 7/5 I. Now that becomes 6 plus 7/5 I. And that's actually your proper answer. You might get full credit from that answer if you gave it on a test. It depends on how picky your teacher is about putting it into a plus bi format. This is absolutely considered the format for complex numbers. So you generally can't go wrong by putting it into a plus bi format. It's just sometimes it creates a little different scenario. In other words, where I cannot simplify that, I can simplify it after I put it into a plus bi format. In other words, this reduces to 6, whereas I can't really do anything with it up here. Because the only thing I can do up here is to divide every term in the top and every term in the bottom by the same number. All right.
Okay.
Let me think for a minute. Okay, here's another one that might give you a little bit of trouble. A little different looking. In other words, as long as you have the full real number and imaginary number in the denominator, you're always going to multiply top and bottom by the conjugate. What are you going to do here? I still have to realify the denominator. How do I make that denominator real?
Multiply it by the conjugate.
Which is?
Negative I.
You got it. And now notice the bottom becomes negative I squared, or 1. The top becomes what?
3 plus 2i squared.
You got to distribute that.
Oh, okay, yeah, so it's negative 3i plus 2i squared.
Yeah, it's just like any variable that you would run into. Now, let's convert that.
So it'd be negative 3i minus 2, sorry, over 1.
Let's put it the minus 2, the real number first, and then minus 3i second, and I don't need the 1 in the denominator, and so I actually have my answer in a plus bi format. Perfect. Okay, so just learn to recognize that that still is a complex number and you still need to multiply it by its conjugate. It's just not readily apparent that the conjugate is minus I. Now, I cannot think of another single tough imaginary number problem. The toughest ones there are that I can even think of are that. Let's see you do this one more time.
So multiply the conjugate, so that'd be 3 minus 5i.
Make sure you always say multiply top and bottom. In other words, I can't multiply the bottom by that. That's changing the value of the fraction. But I can take any fraction and multiply it by the number 1, and that is the number 1. Okay, so you can always multiply fractions by the number 1 and you don't change their value. Okay, what do you get in the bottom?
On the bottom, you'd get the difference of perfect squares. So you'd have 9 minus 25i squared.
Good. The top?
Top, first value is 6. Second value is negative 10i. Third value is negative 9i. And the other value is 15 squared, so add 15 squared. 15i squared, sorry.
Okay, simplify the top.
The top, 15i squared is negative 15. Combine that and the 6, you would get 9. So 9 minus...
Hold on.
Oh.
Negative 9?
Negative 9, sorry.
Okay.
Minus 19i.
Okay, and again, I write the real number first. So that's why I'm always starting there when I'm simplifying. It's because I'm going to take whatever real number that is and combine it with this real number and put that to begin with. Okay, and how about the bottom? What's the bottom become?
Bottoms become 36.
Okay. Now, I just made this up around.
34, sorry. 34.
What's that?
34, sorry, not 36.
Oh, it is 34. Thank you. Wow, it's too bad. 36 was going to allow me to demonstrate one other thing. With 34, now I cannot do anything in the way of simplifying it. Put it into a plus bi format, however.
So you'd have negative 9 over 34 minus 19i. 19 over 34i.
Right. And again, don't put the I in the numerator, put it out there.
Yeah.
And then that's A. B is that. In other words, B is not always plus like it looks like it is. If B is a negative number, then it is. And in this case, it is a negative number. So, and when we first looked at it, and I thought it was 36 also. Well, I would not be able to simplify this at all if it was 36 up here. But once I break it apart, now 9 and 36, that's 1/4. So I'd be able to do this. In other words, this again is a case where you'd be able to simplify the A part, but not the original.
All right.
I got to think you always want to do this step. I had a student yesterday who was just starting imaginary numbers, and they hadn't gotten to the a plus bi part yet. And so all of his answers were like this, but it's clear to me upon looking at this more that you always want to put it in a plus bi format. All right?
All right.
All right, Cole. Well, that's pretty good. You know this stuff well. I don't think I've seen you be so proficient at anything as much as you were today.
Thanks.
Yeah. All right. Keep it up. I'll talk to you next Monday.
All right. Talk to you next Monday.